picture. A place with no name you would recognize. Far to the south, where the land itself has vanished under white. This is Antarctica, and above one certain patch of it, the ice does not stop rising for a very long time. It climbs and climbs, layer after layer of packed snow turned to solid ice, until it reaches nearly 4 kilometers into the sky. That is taller than most mountains you could name. If you stood at the base of it and looked up, you would not even see the top. It would simply fade into a pale, cold haze, too far away for your eyes to follow. Now think of what lies beneath all that weight. Not rock, not frozen ground. Water, a lake dark and still, resting under the entire mass of that ice, hidden so completely that no light has touched it in longer than humans have existed as a species. This is Lake Vostok, one of the largest of what scientists call subglacial lakes. Lakes sealed beneath glaciers, cut off from the sky. It stretches roughly 250 kilometers long, wider in places than some countries are across. And it has likely sat there, undisturbed, for somewhere between 15 and 25 million years. Try to hold that number gently in your mind. 15 million years ago, the continents were already close to where they sit today. Grass had only recently spread across the world. The ancestors of horses were small, forest-dwelling creatures, and through all of that time, through every age of the earth you might have read about, this water has stayed exactly where it is, in the same held breath of darkness, untouched by wind or sun or rain. Before we go further, the planet has a new quiet wonder to share every night. If you'd like one waiting for you each evening, subscribe and let it come to you. The ice above the lake is not just a lid. It behaves more like a slow-moving weight, pressing down where the pressure your body was never built to feel. 4 kilometers of ice bears down on that water with enormous force. And yet, strangely, the lake has not frozen. The pressure itself, combined with a small amount of heat rising from the deep rock below, keeps the water liquid even though its temperature sits below what would normally freeze water at the surface. If you could somehow lower yourself into it, the cold would reach into you almost instantly, but the crushing weight of the water and ice above you would arrive first, and it would arrive everywhere on your body at once. Scientists first suspected something might be down there in the 1970s, when instruments flown over the ice picked up strange, flat signals bouncing back from deep beneath the surface. Flat surfaces, in this kind of reading, often mean liquid water, not stone. It took years of careful work and the layering of many kinds of evidence before researchers felt confident enough to say a lake truly existed under all that frozen weight. Even now, some details about its shape and depth remain incomplete, filled in as much by careful estimation as by direct proof. One idea about lakes like this is that they may hold clues to how life can survive in total isolation, cut off from sunlight and from the rest of the world for immense stretches of time. Another view holds that the water may be closer to lifeless, too pressed down, too starved of nutrients for anything to take hold there. Neither claim has been fully settled. What is agreed upon is that the lake sits in true and permanent darkness, a condition unlike almost anywhere else on the surface of our planet, more like the deep sea than any lake we would recognize by that name. If you imagine standing at the very edge of that ice sheet, feeling the wind pull at your coat, you would have no way of knowing that beneath your boots, kilometers down, an entire lake waits in silence. No birds fly over it. No waves move across it. The wind you feel would never reach the water below, not in your lifetime, not in the memory of your grandchildren. It is a place utterly separate from the sky, and yet it is only just below where you stand. Tonight, we begin here, at the edge of that impossible ceiling of ice, thinking about what it means for something to be sealed away for so long that human history is only a flicker against its silence. We will move slowly downward, section by section, the way the ice itself moved down through the ages. And we will sit with the questions that remain, because so much about this lake, even now, is still unknown. Let's start with something simple. A lake, sitting still, holding water. That much you already know. You have seen lakes before. You may have swum in one, or watched the sunset over one, or skipped a stone across its surface. Now take that picture and put it somewhere it does not belong. Put it under 4 kilometers of solid ice. That is nearly 2.5 miles of frozen weight, stacked in layers older than any city on Earth. This is Lake Vostok, and it sits beneath the ice of Antarctica, in a place so remote and so cold that almost nothing about it feels familiar. Picture standing at the base of a mountain 4 kilometers tall. Now imagine that mountain is made entirely of ice, pressing down, layer after layer, year after year. That is roughly the depth researchers had to reach before they found water instead of more ice. The lake itself stretches about 250 kilometers long and about 50 kilometers across at its widest point. That makes it similar in size to Lake Ontario, one of the Great Lakes you may have heard of, sitting quietly on the border between the United States and Canada. Only this one has no shoreline you could walk, no boats, no birds circling above it, no above, in any way you would recognize. The water itself is old, not old like a historic building or an ancient tree, old like something that has not touched open air since before early humans walked anywhere on Earth. Some estimates suggest this lake has been sealed beneath its icy lid for somewhere between 15 and 25 million years. The exact number remains a question researchers still debate, because dating water that has never been exposed to sunlight or rain is a delicate kind of guesswork. What most agree on is this: whatever sky last shone above this water, it shone in a world without us in it. Depth is another figure that resists easy imagining. In places, the lake reaches depths of over 500 meters. That is deeper than most lakes you could name from memory, deeper than many stretches of open ocean near a coastline. And yet none of that depth has ever known a single ray of sunlight, not a flicker, not a glow. The darkness here is not like closing your eyes in a dim room. It is a permanent condition, the same in every direction, without change, without a version of day. If you tried to imagine floating in this water, the first sensation would not be cold, though the cold would be severe. It would be pressure. The weight of an entire ice sheet above you would press down with a force your body has never once experienced. Not in the deepest pool, not in any ocean dive most people ever attempt. Some researchers believe this pressure is part of the reason the lake stays liquid at all, even in temperatures that would freeze water anywhere else. Others point to a slow warmth rising from the rock far below, heat left over from the Earth's own depths, gently working against the cold from above. Both forces likely play some role. Which one matters more, and by how much, remains an open question glaciologists continue to study. The lake's temperature sits far below the freezing point most people know from a home freezer or a winter pond, and still it does not freeze solid. Pressure and hidden warmth strike a fragile balance most people never think about, holding the water in a strange glassy stillness that has lasted for millions of years without interruption. There is no current here worth mentioning, no wind to stir a ripple, no tide pulled by any moon. If you dropped a single object into this water, in theory, it might drift for a very long time before settling, moving through a silence with no equivalent on the surface of the planet. Sound behaves differently here too, swallowed by pressure and distance, though scientists are still working out exactly how. What makes this lake different from an ordinary body of water is not really its size, or even its darkness. It is the seal. 4 kilometers of ice sit above it like a lid that has never once been lifted, not fully, not completely, not in the whole span of human history. Somewhere on the surface far above, snow falls gently onto a white and endless field, unaware of the ancient water resting far beneath it. You would never guess, standing there, that something so old and so still waited just beneath your boots. For now, remember the simple shape of it, a lake, old beyond memory, sealed beneath a mountain of ice, holding a darkness that has never once been broken. Everything else we explore tonight builds from this quiet, patient fact. No one set out looking for a lake under the ice. That is part of what makes this story so quiet and so strange. The people who found it were not exploring. They were flying planes back and forth over Antarctica, measuring something else entirely, and the lake simply appeared in their data, waiting. The first hints came in the 1950s and 1960s from Russian and British survey teams using a method called radio echo sounding. That is a way of sending radio waves down through ice and listening for what bounces back. Ice gives one kind of echo, rock gives another, but in a few places deep beneath East Antarctica, the echo that came back was flat, smooth, and sharp, like light reflecting off still water. Rock does not reflect that way, only a liquid surface does. For years, this was treated as a curiosity, almost a footnote. Imagine you are looking at a shadow on an old photograph, and it looks like it might be a lake, but you cannot walk there to check. The scientists reading these echoes in the 1970s did not have a way to confirm what they were seeing. They wrote it down. They moved on to other questions. The idea sat in journals, mostly unread, for decades. The picture changed with satellites. Starting in the 1990s, instruments in orbit began measuring the surface of the ice sheet with incredible precision, mapping its height across thousands of miles. Ice that sits on solid rock behaves one way. Ice that floats on a hidden body of water behaves differently. It sags, it settles. In places, it forms a shallow depression, almost like a very slow, very slight dimple pressed into a ceiling from below. When researchers matched these dimples to the old radar echoes, the two kinds of evidence lined up. A lake was not just likely, it was there. This is how Lake Vostok came to be confirmed in the early 1990s, resting about 4 kilometers beneath a research station that had been operating on the ice above it for years, without anyone knowing what it was sitting on. Think about that for a moment. People had eaten meals, slept, and done their daily work directly above a lake the size of some countries, and none of them knew it was there. You could stand in a spot like that yourself, on ground that looks like any other stretch of white, and have no way of knowing an entire hidden world of water waits far below your boots. How did the lake itself come to exist? This is where the story turns from discovery to deep time, and the science becomes more of an open question than an answer. One leading idea is that Lake Vostok sits in a basin carved by tectonic activity long before the ice sheet ever formed, perhaps related to old fault lines in the bedrock, a low place in the land that water later filled. Antarctica was not always covered in ice. Around 34 million years ago, the continent began to freeze over in earnest, and as the ice sheet grew thicker and thicker, it sealed whatever water systems existed underneath it. A competing idea suggests the lake is younger than the ice itself and formed more gradually, fed slowly over millions of years by heat rising from the rock below and by the immense pressure of the ice sheet pressing down from above. That pressure, combined with heat escaping from the Earth's interior, can melt ice from its underside even when the surface stays frozen solid. Under this view, the lake is less like a fossil left behind and more like something still being made, drop by drop, over unthinkable stretches of time. The two ideas are not fully separate. Both may be part of the truth. The basin may be ancient, shaped by rock, while the water inside it keeps forming and reforming under pressure and heat that never let up. What researchers agree on is the scale of time involved. Ice cores drilled nearby suggest the lake has likely been sealed away, cut off from the sky, for somewhere between 15 and 25 million years, long before the first humans walked anywhere on Earth. This water was already resting in the dark. No one can say with full certainty which theory explains its birth, or whether some third explanation, not yet imagined, comes closer to the truth. The ice above keeps its record, but the ice does not explain everything it hides. For now, the origin of this lake remains part guess, part evidence, and part quiet wonder, waiting the way the water itself waits, patient and unlit, for someone to ask the right question. Once scientists suspected the lake was real, a new question took hold. How do you touch something buried under 4 kilometers of ice without breaking it? The answer, it turned out, would take decades to work through, and it would test the patience of entire research teams. Drilling through ice sounds simple. It is not. Ice near the surface is cold and brittle, but a few kilometers down, it grows warmer and softer under its own weight. Drill bits can freeze in place. Boreholes can close behind the drill, like water sealing over a dropped stone. Engineers had to build machines that could melt or cut through ice for days at a time, lowering cables thinner than a garden hose into a hole that stretched taller than most mountains are wide. If you stood at the surface camp during this work, you would feel nothing dramatic happening beneath your boots. The drilling is quiet, slow, almost bored in its patience, yet it inches towards something that has not felt a human tool in millions of years. The ice itself is made of ordinary water, frozen in layers like the pages of a very old book. Each layer holds tiny bubbles of ancient air, trapped snow that fell long before anyone kept written records. As the drill descends, it passes through ice that fell as snow during ice ages, through eras when woolly mammoths walked warmer ground far to the north. Every meter down is a meter back in time. Researchers read these layers the way you might read growth rings in a tree, though this record can stretch back hundreds of thousands of years, sometimes longer. But near the very bottom, something changes. The ice grows clearer, wetter, less like solid rock, and more like something that remembers being liquid. This is where the drill must slow to almost nothing. Teams stopped their equipment meters above the suspected surface of the lake, deliberately, cautiously, unwilling to plunge straight through. The fear was contamination, bringing drilling fluid, surface microbes, or trapped air down into water that had never mixed with the modern world. One approach uses clean, filtered water instead of chemical fluid, melting a narrow path down rather than cutting one. Another idea proposes letting a small amount of lake water rise up into the borehole under its own pressure, sampling it without ever sending anything down at all. Both methods try to solve the same problem from opposite directions, and neither is universally agreed upon as the safest choice. What lies at the bottom, chemically speaking, is still argued over in fragments. The ice itself is nearly pure water, frozen from snow that fell over unimaginable stretches of time, but dissolved within the lake water below. Researchers expect salts, minerals worn slowly from ancient bedrock, and gases that have had nowhere to escape to for ages. Some studies of meltwater near the borehole have found signs of nitrogen and oxygen locked into the ice at surprisingly high concentrations, hinting that the lake beneath may be unusually rich in dissolved gas, pressurized by the weight above it, rather than released the way gas escapes from a soda bottle opened at the surface. Whether this gas comes from ancient air trapped when the ice first formed, or from chemical reactions happening slowly in the dark rock below, remains an open question, with real disagreement among the teams studying it. There is something almost humbling in this detail. The oxygen you breathe tonight shares a distant kinship with gas that may be sealed in water at the bottom of the world. Gas that has waited in darkness since before there were eyes to notice light at all. The rock beneath the lake, too, connects outward. Minerals in continental bedrock, everywhere traced back to the same slow churn of the planet's crust, the same ancient collisions and coolings that built every mountain range and ocean basin you have ever seen. The lake is not separate from the rest of Earth's story. It is a locked room inside a house that is still, in its own slow way, one connected structure. And yet, the specifics of what swirls in that locked room stay frustratingly uncertain. Estimates of salinity, temperature, and gas content shift with each new study, each refined instrument. Some measurements suggest water nearly as cold as salt water can get before freezing. Others suggest pockets that may be slightly warmer, heated faintly from below by the rock itself. No one has yet drawn a clean, agreed-upon map of what fills that water from top to bottom. The drill continues its slow work, meter by careful meter, and the silence above the lake remains, for now, mostly intact. Picture, standing on the ice above this lake, 4 kilometers of frozen white stretch beneath your boots, and somewhere far under that weight, water moves without ever turning to ice. This seems strange at first. The air just above that ice can drop past minus 50 degrees Celsius. By every simple rule, the water below should be a solid block, still and frozen through. It is not. It stays liquid. The reasons why are not fully settled, and that uncertainty is part of what keeps researchers awake at night, wondering. The first force at work is pressure, and pressure here is almost impossible to picture. 4 kilometers of ice weighs an enormous amount, and all of that weight presses straight down on the water below. Pressure changes the point at which water freezes under. Enough of it, water can stay liquid at temperatures that would freeze it solid anywhere near the surface. Think of squeezing a block of ice hard enough between your palms that it resists turning solid again. The ice sheet does something like that, but on a scale no hand could ever match. Pressure alone may not explain everything, though. A second force comes from below, not above. The Earth's interior holds heat left over from its formation, and slow decay of radioactive elements in the rock keeps adding a little more. This is called geothermal heat, warmth that rises up through rock from deep inside the planet. It moves slowly, but it never stops. Under thick ice, that heat has nowhere fast to escape. It gathers, and some researchers believe it plays a real part in keeping this water from freezing. There is disagreement about how much credit each force deserves. Some scientists lean toward pressure as the main reason the lake stays liquid. Others argue that without steady heat rising from below, pressure by itself would not be enough over long stretches of time. The truth may be some careful mix of both, working together in ways that are still being measured and modeled. Nobody has climbed inside to check directly. So much of this rests on instruments, equations, and educated guessing. Then there is the ice itself, acting almost like a blanket. Ice is a poor conductor of heat, which means it does not let warmth pass through it easily. 4 kilometers of it traps heat underneath the way a thick quilt traps warmth around a sleeping body. Cold air above never reaches the water below, no matter how fierce the wind gets on the surface. If you tucked a candle under a mountain of blankets, its small warmth would linger far longer than you might expect. This lake may be living inside something like that. Insulated by its own frozen lid, movement plays a role too, though a slow and quiet one. The ice sheet above is not still. It creeps forward inch by inch, dragged by gravity and its own enormous weight. As it moves, it flexes and grinds against the rock, and water beneath it, that friction, creates a small amount of extra heat, added to whatever rises from below. It is a gentle contribution compared to the deep heat of the planet, but in a place this finely balanced, small contributions may matter more than they would anywhere else. If you could somehow float in this water, none of these forces would announce themselves to your senses. There would be no headline warmth, no current pushing you one way or another. The cold would still reach you fast, because liquid water near freezing is nothing gentle against skin, even if it never quite crosses into ice. The pressure pressing on your body would be many times greater than anything felt at the surface of the sea. Your senses would tell you only stillness and weight, while unseen forces held that stillness in perfect, fragile balance. What remains unresolved is how stable this balance truly is. Some researchers wonder whether shifts in ice thickness over thousands of years could tip that balance, letting parts of the lake freeze or forcing more water to stay liquid than before. Others see the system as remarkably steady, a slow equilibrium that has held for a very long time. No one has measured it long enough or closely enough to say for certain which view is closer to the truth. For now, the lake stays liquid in the dark, held there by pressure from above, heat from below, and the slow patience of an ice sheet acting like a lid. Whether that balance has held unbroken for millions of years, or has shifted quietly more than once, is still an open question. It is the kind of question best carried gently into sleep, not answered tonight. Let's try to feel the size of this place, because numbers alone slide past us in the dark. 4 kilometers of ice sit above the lake we are describing tonight. If you stacked 10 of the tallest buildings most people have ever seen, one on top of the other, you would still be reaching up toward the bottom of that ice, not the top of it. That is the ceiling. That is what separates this water from the sky. Now think about weight instead of height. Ice seems light when you hold a cube of it in your hand. It floats. It melts in your palm in minutes, but 4 kilometers of it, packed down over hundreds of thousands of years, is not light at all. Each square meter of that ice sheet presses down with a force close to 400 times the pressure of the air around you right now. If you could stand on the lake floor beneath it and somehow survive the cold and the crushing weight for even a moment, your body would feel a pressure similar to being nearly 400 meters underwater in the open ocean. Your lungs, your blood, the small pockets of air inside your joints, all of it would respond to a force most human bodies never encounter anywhere for any reason. That pressure is part of the reason the lake is liquid at all. We touched on this before, but the scale of it deserves a slower look. The ice above does not just sit there quietly. It pushes, and that push lowers the temperature at which water below it can freeze. In the same way, pressing down hard on a snowball turns some of its surface to slush. The water in the lake may sit close to freezing by our standards, but it holds its liquid form because the weight above it has changed the rules water normally follows. Scientists call this pressure melting, and it is one of the more settled parts of this mystery. What remains far less settled is exactly how the heat below, rising slowly from the rock beneath the lake, interacts with that pressure over long stretches of time. Some researchers think the balance has held steady for millions of years. Others wonder if it shifts slowly, in ways too slow for any instrument to catch mid-motion. Distance is another way to feel this place. The lake itself may stretch longer than many countries are wide, a body of water tucked under ice with no visible edge, no shoreline anyone has walked. If you tried to cross it by boat, and if a boat could somehow exist in that dark, the trip could take hours, gliding over water that has not felt wind or light in longer than our species has existed. There is no wave to rock that boat. There is no current to drift it sideways. The stillness itself is part of the scale, a kind of quiet that has no real comparison on the surface of the earth, where wind and tide and sound never fully disappear. Then there is time, which may be the hardest scale of all to hold in your mind. The ice above the lake did not form last year or last century. Some of the deepest layers of that ice sheet may be close to 1 million years old, laid down snowfall by snowfall, winter after winter, long before any human eye watched the sky. The water beneath it may be older still, isolated long enough that it predates not just human history, but much of what we would recognize as the modern shape of the world's oceans and coastlines. If you tried to picture that stretch of time as a single night's sleep, it would be like closing your eyes for one moment and opening them long after every mountain range you know had shifted into a different shape. Cold belongs in this picture too. The water sits near the freezing point, but the air far above it, at the surface of the ice sheet, can drop to temperatures that would injure exposed skin within minutes. Down at the lake itself, the cold is steadier, quieter, wrapped in rock and ice instead of wind. It is not the sharp cold of a winter morning. It is a slow, patient cold that has had nowhere to go and nothing to disturb it for a very long time. None of these numbers on their own explain what the lake is or what, if anything, lives inside it. They only give us a frame large enough to hold the mystery without losing its shape. The weight above, the distance across, the years piled behind it, all point toward the same quiet question we keep returning to. Something ordinary, water, sitting in conditions almost nothing on the surface of our planet ever faces. We are left holding the scale at it, turning it over slowly, still uncertain what waits inside. Picture, for a moment, a ceiling that has never once opened. Not a door left shut, not a lid someone forgot to lift. A ceiling that has simply never been anything but closed, for longer than there have been eyes to notice it. That is the surface of the lake we are speaking of tonight. 4 kilometers of ice sit above it, layer upon layer, laid down snowfall by snowfall, across hundreds of thousands of years. If you could somehow float just above the water itself, there would be no sky to look up at. There would be only ice pressing down, glowing faintly blue in places where old air bubbles catch what little light manages to travel that far. But even that description is generous. At the true surface of the lake, there is no light at all. None has arrived there in millions of years. Try to hold that number gently in your mind, the way you might hold a stone you are not sure how heavy it is. Millions of years, long before the first human foot pressed into soft earth anywhere on this planet, this water was already resting in darkness. Ice ages came and went far above. Forests grew and then turned to something else entirely. Rivers changed course 1,000 times over. And through all of it, this lake simply stayed sealed, untouched, unaware in any way we could measure that a world was changing so far above its ceiling. If you stood where the ice meets the water, though no person ever has, the cold would not announce itself the way cold does on a winter morning. It would simply be there, absolute and unchanging, the same temperature it has likely held for ages. The water beneath that ice is kept from freezing solid, not by warmth, but by pressure, an idea we touched on earlier, and one worth sitting with again. The weight of the ice above pushes down with such force that it lowers the point at which water turns to ice. So the lake stays liquid, cold as it is, simply because nothing in the world above pushes on it in quite the same way again until you reach its icy roof. The texture of that roof, if such a thing could be described, is not smooth. Ice scientists who study the layers above these hidden lakes tell us the underside of the ice sheet is not flat like a frozen pond. It ripples and shifts in slow, geological time, shaped by pressure from below and by the impossibly slow flow of the ice itself, which moves the way honey moves, just far too slowly for our eyes to ever catch it happening. Some researchers believe the lake's surface reflects this rippling ceiling above it, echoing its shape the way a mirror might echo a face, only over spans of centuries rather than seconds. We do not know, with any real certainty, what color the water is. Some who study these lakes suspect it may be nearly clear, having had so long to settle, with almost nothing stirring it. Others wonder if fine mineral dust, ground down by the slow grinding of ancient rock beneath the ice, might tint it faintly, giving it a color we would need instruments, not eyes, to detect. Without light, color, as we understand it, barely applies at all. Color needs something to bounce off of, and here there is nothing arriving to bounce. The silence of that surface deserves its own quiet moment. There is no wind to move across it, because there is no air above it in any open sense, no sky for weather to gather in. There is no wave, because nothing disturbs it enough to create one. If you could somehow listen at that boundary between ice and water, you would hear nothing at any frequency, not a hum, not a whisper, not the pop of settling ice. Some researchers who have lowered sensitive instruments near such places describe a stillness that is almost difficult to hold in the mind, so complete that our own bodies full of small sounds and rhythms feel loud by comparison. And yet, this is only the surface, the outermost skin of something we still barely understand. What lies beneath that still, dark ceiling? How deep the water reaches, and whether anything moves within it at all, remains an open question we will sit with further as we go. For now, simply hold the image of that vast, lightless roof, patient and unmoved, exactly where it has been for longer than memory itself, waiting without waiting for anyone at all. Picture the water itself resting under all that ice. It is black, colder than most seawater, and pressed by a weight that would flatten almost anything that came from the world above. No sunlight has ever touched it, no wind has ever stirred it. And yet the question that keeps scientists awake at night is a simple one. Could something be alive down there? The idea sounds strange at first, a lake, with no light, no plants, no way to make food the way we understand it. But life on Earth has a long history of surprising us in dark places, deep in caves, near boiling vents on the ocean floor, inside solid rock a mile underground. Tiny organisms have been found living on chemistry alone. Some scientists think a sealed lake under 4 kilometers of ice could hold a version of that same trick. One theory centers on the rock beneath the lake. If minerals in that stone slowly react with the water, they might release small amounts of chemical energy. Some microbes on the surface world already know how to use energy like this instead of sunlight. If the right minerals and the right microbes both exist down there, together, then a very slow, very quiet kind of life might be possible. Not fish, not anything with eyes, since eyes would be useless in a place that has never known light. Perhaps something closer to a single-celled organism, patient and small, adapted to a world where nothing ever changes. But there is a competing view. Just as reasonable, some researchers point out that the lake has been sealed for a very long time, possibly for millions of years. In that time, oxygen would have been used up quickly, unless something keeps replacing it. Without a steady source of chemical energy, an isolated body of water like this might become a kind of chemical dead end. Under this view, the lake could be sterile, not because life is impossible in dark places, but because this particular lake may lack the ingredients it would need to keep any life going for so long. The honest answer is that nobody knows yet, and that not knowing is part of what makes the lake so compelling. A few subglacial lakes elsewhere in Antarctica have already been sampled carefully through narrow boreholes drilled with extreme caution. In some of those samples, researchers found genetic traces of microbes, tiny fragments of DNA that suggested some kind of life had been present, or had once passed through. But contamination is always a risk when you drill from the surface down into something this pristine. And separating a true resident of the lake from something carried in by the drill itself is a difficult, careful process. Some results are still debated. Some may never be fully resolved. If you could send a hand down into that water, past the last few meters of ice, past the seal that has held for so long, you would feel a cold that moves differently than cold on the surface. The pressure alone would press against you the way ocean depths do. Slow and total, nothing like a gust of wind or a splash of icy water at home. There would be no sound to guide you, no shape to see, only the sense of something vast and still, holding whatever secrets it holds, entirely unbothered by your presence. Some scientists wonder if the true value of these lakes is not proving life exists, but understanding the limits of where life can survive at all. If a subglacial lake can support even the simplest microbe, it changes how we think about other dark, sealed, extreme places, including some far beyond Earth. If a lake like this turns out to be empty, that too tells us something, a boundary line for what life needs and where it cannot go, even when given millions of years to try. For now, the black water keeps its answer to itself. Every sample pulled up so far raises more questions than it settles. Every new lake found beneath the ice adds another sealed room to a hidden system nobody has fully mapped. Whether something small and quiet moves through that darkness, adapted to a world without light or warmth, or whether the lake sits utterly still and lifeless, waiting only for chemistry and pressure to shape its silence, remains an open question. The dark itself may be the closest thing to an answer we have, at least for now. Every living thing you know depends on a rhythm. Day turns into night, the sun rises and falls. Plants use that light to make food, and everything else follows behind, eating plants or eating each other. This lake, sealed under 4 kilometers of ice, has none of that. No sunrise has touched it in millions of years. If there is life down there, it has to run on a completely different kind of clock, or perhaps no clock at all. On the surface of the earth, the seasons turn everything, rivers rise and fall, forests bud and drop their leaves, animals wake and sleep by the changing light under the ice. None of that reaches down. The water sits at a steady, crushing pressure, in a cold that never shifts with the calendar above. There is no spring here, no autumn. Whatever cycles might exist would have to be built from something other than light and warmth. One idea scientists have explored is chemical cycling, even without sunlight. Some microbes on the surface world already survive by breaking apart minerals for energy, a process called chemosynthesis, where chemical reactions replace what light usually provides. If Tiny organisms live in this lake. They might feed on chemicals released slowly from the rock below, cycling elements like iron or sulfur, the way surface life cycles carbon through breathing and growing. This would be a rhythm without seasons, a slow chemical breathing that could take centuries to complete. One turn, ice itself moves, even though it looks frozen still from above. The great sheet above this lake creeps forward inch by inch, year after year, pulled by gravity and its own enormous weight. As it does, pressure at the base shifts slightly, and some researchers wonder if this creates a faint, almost imperceptible pulse in the lake below, a rhythm measured in centuries rather than hours. If you rested your hand against the ice above this lake, you would feel nothing move. Yet deep below your palm, the whole sheet inches forward, quiet and relentless. There is also the matter of meltwater, where the ice sheet touches the bedrock. Friction and the Earth's own internal heat can melt a thin film of water at the base. That water sometimes drains toward this lake, and sometimes drains away again, in ongoing cycles that can take years or decades to complete. Some subglacial lakes elsewhere have been observed rising and falling, filling slowly and releasing water through hidden channels beneath the ice, like a very slow hidden tide with no moon to pull it. Whether this particular lake breathes in that way is still an open question. Instruments on the surface have detected subtle shifts in the ice above certain subglacial lakes, hints that water moves in and out over time. For this lake, the evidence remains thin, pieced together from careful measurements taken from far above, never confirmed by direct and repeated observation. The cycle, if it exists, has never been watched from beginning to end. If there is life here, it likely does not experience time the way surface creatures do. A surface bacterium might multiply within hours. Down here, in extreme cold and near total isolation, growth might slow to a crawl, with some scientists estimating that microbial generations in comparable extreme environments could stretch across hundreds or even thousands of years. If true, an organism living now might be, in some sense, the same individual that existed when the first stone tools were shaped by human hands above the ice. Competing theories exist about whether any biological cycle operates here at all. Some researchers propose the lake may be almost entirely sterile, its chemistry too harsh, its nutrients too scarce, its isolation too complete for anything to sustain a population, let alone a rhythm of birth and renewal. Others argue that life is remarkably persistent, and that wherever liquid water exists, however extreme the conditions, some process usually finds a way to use it. Neither view has been proven. Samples taken from related subglacial environments have shown promising signs of microbial DNA. Yet contamination during drilling makes some of those signs difficult to trust completely. What remains certain is that whatever rhythm exists here, it moves at a pace almost impossible for a human mind to hold on to. If you tried to watch one full cycle of this lake's slow chemistry, you might wait a lifetime and see nothing change. The clock down there, if it ticks at all, ticks in a language written by pressure, mineral, and endless patient cold, rather than by light. We do not yet know if it beats at all, only that somewhere beneath the ice, time itself may be moving differently than anywhere you have ever stood. Think of the lake as a bottle sealed a very long time ago. Inside that bottle, the water has not stayed still in a chemical sense, even if it has stayed still in every other way. Rock touches water at the bottom of the lake. Ice touches water at the top. Over hundreds of thousands of years, slow reactions between stone and liquid change what the water carries inside it. Salts dissolve, minerals shift, Gases seep in from the rock below, one molecule at a time, in a process too slow for any clock we use above ground. This makes the lake something like a closed chemistry set, but one that no one has ever opened to check the results. Researchers who study it call this idea geochemical isolation, which simply means the water has been cut off long enough to develop its own private mix of elements. If you dropped a single glass of that water on a table, it might look plain, but dissolved inside it could be traces of iron, sulfur, and gases that tell a story about rock nobody has touched in millions of years. The neighbors here are not other lakes or rivers. The neighbors are the stone below and the ice above, and both have been quietly changing the water for longer than our species has existed. One theory holds that the chemistry of the lake reflects the bedrock underneath the ice sheet, a floor of ancient rock shaped long before any glacier formed. If that is true, sampling the water carefully could tell us what kind of stone lies beneath, without ever drilling into it directly. Some researchers picture this as a kind of chemical fingerprint, left behind the way a hand leaves an oil mark on glass. Other scientists are more careful. They point out that meltwater from the ice above may also feed into the lake, carrying its own dissolved gases from trapped air bubbles that formed long ago. If that mixing happens, the water may be telling two stories at once, one from below and one from above, tangled together in a way that is hard to separate. This matters because gas trapped in the water might include oxygen and nitrogen from an atmosphere that existed before recent ice ages. If you could hold a sealed vial of that water in your hand, you would be holding air breathed by no living thing we know of, air that settled into ice and dissolved into liquid long before written history began. That thought alone is enough to keep a person awake with wonder. Except tonight, we let it settle instead, like sediment sinking slowly through still water. The pressure down there also changes how gases behave. At 4 kilometers of depth, gases can stay dissolved in water at concentrations that would be impossible near the surface. If the pressure was suddenly released, dissolved gas could rush out all at once, the way a shaken soda bottle fizzes when opened. This is one reason scientists worry about contact with the lake at all. A rise in pressure release, even a small one, could carry gas and material up through a drill hole in ways hard to predict. No one is certain how large that risk truly is, and estimates vary a great deal depending on which model a team chooses to trust. There is also the mineral question. Some researchers believe the lake floor may hold a thin layer of ancient sediment, slowly built from dust, rock flour, and mineral grains carried in by meltwater over enormous stretches of time. If sediment cores could ever be pulled up gently, they might record clues about the climate of Antarctica from long before human memory. But other scientists caution that we do not yet know how thick that sediment layer is, or whether the lake bottom has been disturbed by slow currents, driven by heat rising from the rock below. Until a full physical sample is taken, this remains an open question, resting quietly at the bottom of the dark. What we can say is that the lake does not sit in isolation from the world around it. Even sealed as it is, it exchanges slow whispers of chemistry with the rock beneath and the ice above, the way two neighbors might pass notes under a door for 100,000 years. Nothing rushes, nothing announces itself. The exchange happens, one molecule, one mineral grain, one bubble of ancient gas at a time. If you imagine standing at the edge of that hidden shoreline, the water would look like any other, dark and still and cold, but everything about its chemistry would carry the fingerprints of two worlds pressing quietly against each other in total silence, waiting, as it always has, for someone to finally ask the right question and listen closely to the answer written in stone and water. Think for a moment about the last few meters. When engineers finally drilled close to the surface of Lake Vostok, deep under the Antarctic ice, they stopped on purpose. They stopped before the drill bit touched the water at all. That pause, held for years, tells you something about how carefully people think about a place like this. It is not fear in the dramatic sense. It is caution, born from knowing you cannot take a mistake back. The lake sits under nearly 4 kilometers of ice, in one of the coldest, most isolated places on the planet. The pressure down there is immense, more than 300 times what you feel standing at sea level. If your body were somehow lowered into that water, the crushing force would act on you long before the cold could finish the job. Your chest would feel the weight first, a slow squeeze building from every direction at once. This is not a place built for anything shaped like you. The record-breaking numbers pile up quickly once you start listing them. Lake Vostok is one of the largest subglacial lakes ever found, stretching roughly 250 kilometers long. Its water may have been sealed away from open air for somewhere between 15 and 25 million years, though the exact number is still debated among researchers. Some estimates run even older. Either way, the isolation is staggering. Humans had not yet evolved when this water last felt open sky. Cold as it is, the lake should be frozen. Temperature down there sits well below 0 degrees Celsius. What keeps it liquid is the pressure of all that ice pressing down, along with a small amount of geothermal heat rising from the rock below. Water behaves strangely under these conditions. Pressure can lower its freezing point past what feels reasonable, holding it liquid in a state that seems to defy the cold surrounding it. It is one of the more elegant tricks of basic physics, playing out in total silence, far from anyone who might witness it. This is where the risk of contamination becomes real. Every drill, every cable, every tool lowered toward that surface carries a small trace of our world. Microbes from the air, chemicals from machine oil, even warmth from friction. All of it threatens to leave a mark on something that has stayed untouched for millions of years. Researchers worry about two things happening at once: contaminating the lake with material from above, and destroying evidence of whatever unique chemistry or life might already exist below. Once broken, that kind of seal cannot be reset. Some scientists argue the risk is manageable with the right filters and sterile drilling fluid. Kerosene and freon mixtures, once used in early drilling attempts, have already raised concern about what leaked into the lake's uppermost layers. Other researchers take a more cautious stance, arguing that any contact at all changes the experiment permanently, no matter how careful the tools. There is no controlled version of this test. You only get to do it once. If you imagine standing at the drill site, the surface world looks almost peaceful. Wind moves across flat white ice under a pale sky, and nothing about the view hints at the scale of what waits below. But under your boots, 4 kilometers down, sits a body of water larger than many lakes you could name on a map, held in permanent dark, permanent cold, permanent silence. The disconnect between the surface calm and the deep unknown is part of what makes this place so hard to look away from. Pressure. This extreme changes how everything behaves, including gases dissolved in the water. Some researchers believe the lake holds unusually high concentrations of dissolved oxygen and nitrogen, locked in by the weight above, unable to escape the way gas would in open water. If disturbed too quickly, some worry that these gases could behave unpredictably, almost like opening a bottle that has been shaken for millions of years. Others think the effect would be far more subtle, barely noticeable outside careful instruments. No one has tested this directly, And the honest answer is that no one fully knows. The extremes stack on top of each other here. Extreme age, extreme pressure, extreme isolation, extreme uncertainty. Each one on its own would be worth wondering about. Together, they turn this single lake beneath the ice into one of the most delicate scientific frontiers on the planet, a place where curiosity has to move slower than instinct, and where every extreme measurement only deepens the mystery instead of settling it. For a long time, people thought there was only one lake like this, one dark pool under one sheet of ice, alone at the bottom of the world. That idea has quietly fallen apart. Scientists now count more than 600 subglacial lakes beneath the Antarctic ice. Most are small. A few are enormous. All of them share the same strange condition, sealed away from the sky, pressed flat under ice that has not moved in ways we would notice in a human lifetime. Think about that number for a moment. 600. Each one sits in its own pocket of stone and ice, some close together, some separated by hundreds of miles of frozen ground. They were not placed there. They formed slowly over long stretches of time, as heat from the deep earth met the underside of the ice and coaxed a little water into staying liquid. No one designed this system. It simply happened the way rivers happen, the way caves happen, shaped by pressure and patience rather than any plan. Researchers found most of these lakes the same careful way they found the first one. They flew instruments over the ice in slow, low passes, sending radar waves down through the frozen mass above. Ice reflects radar in one way. Liquid water reflects it in another. When the signal came back flat and bright, almost like a mirror, it meant something smooth and wet was sitting far below. Each flat echo became a quiet clue, a soft knock from beneath the ice, saying something is here. Some of these lakes are barely bigger than a small pond. Others stretch for dozens of miles, wide enough that if you stood at one edge in total darkness, you would have no way of sensing the far shore. The differences between them raise a gentle, open question. If the conditions vary this much from lake to lake, do the small hidden worlds inside them vary too? One idea is that each lake might hold its own quiet chemistry, its own faint trace of ancient air, its own slightly different balance of minerals dissolved from the rock below. Another idea suggests the lakes might be more alike than different, all shaped by the same slow physics pressing down from above. Both ideas remain open because so few of these lakes have ever been sampled directly. What makes this even more delicate is the way many of these lakes seem to be linked. Beneath parts of the ice, thin films of meltwater appear to move slowly from one lake to another, threading through hidden channels scientists still cannot fully map. If this picture holds, the ice sheet is not simply sitting on top of 600 separate lakes. It may be resting above something closer to a slow, hidden network, one lake feeding gently into the next over centuries. No one has confirmed how far this network reaches, or how connected it truly is. The evidence so far comes from patterns in the ice surface itself, subtle rises and dips that hint at water shifting somewhere far below. There is a quiet beauty in imagining a system at work. Picture a lake the size of a small sea, black and silent, joined by the faintest thread of moving water to another lake many miles away, which is joined to another and another, spreading beneath the ice like a hidden root system beneath a forest floor. No sunlight touches any part of it. No wind stirs its surface, and yet, in its own slow way, it may be alive with motion, water inching from one hidden chamber to the next, over spans of time too long for a human mind to feel. If you tried to picture standing above any one of these lakes, the ice beneath your boots would look no different from any other icy plain. There would be no sign, no shimmer, no clue that something vast and wet waits far below. That is part of what makes this mystery so quiet. The surface gives nothing away. Scientists have only begun to study a small handful of these lakes closely. The rest remain little more than radar echoes and rough outlines, waiting for future missions with more time, better instruments, and steadier funding. Each one is a small, sealed world of its own, holding its own possible answers about chemistry, pressure, and perhaps life in conditions with no light at all. Whether they are truly connected, and what that connection might carry between them, is still an open question, resting quietly under the ice, waiting for someone to ask it more closely. For a long time, most people imagined the ice sheets of Antarctica as one solid, silent mass, frozen from top to bottom, still like a held breath. But this picture, we now understand, was too simple. Under that ice, water moves. Slowly, in the dark, without any wind to push it, rivers and lakes shift and connect in ways no one on the surface could see. The first hints came from an unlikely place. Radar. In the 1960s and 1970s, researchers began flying instruments over the ice. They could send radio waves down through the frozen layers. Ice, it turns out, is mostly transparent to certain radio frequencies. The waves pass through miles of it and bounce back when they hit something different. Rock gives one kind of echo. Water gives another, flat, bright, and strangely mirror-like. When early radar teams saw these bright, flat echoes appearing again and again, far beneath the surface, they were not entirely sure what they were looking at. At first, some scientists assumed these signals were simply errors, static, a trick of the instruments. It seemed hard to believe that liquid water could exist under so much frozen weight, in temperatures that should have turned it to solid ice. But the signal kept appearing in place after place, always with that same flat brightness. Slowly, the idea took hold that these were not mistakes at all. They were lakes, real bodies of liquid water, sealed away under kilometers of ice, in total darkness. One name closely tied to this discovery is a lake found near a Russian research station. Sitting under nearly 4 kilometers of ice, researchers had worked at that station for years, drilling ice cores to study ancient climate, layer by layer, like reading the rings of a very cold tree. It was only later, once the radar data was combined with other measurements, that the full shape of what lay beneath became clear. A lake roughly the size of a large freshwater lake on the surface, hidden the entire time underneath the researchers' boots. As more radar surveys were flown, more of these lakes appeared, not just one, but dozens, then hundreds, scattered beneath the Antarctic ice. And this is where the picture became even stranger. These lakes were not always isolated pools, sitting quietly on their own. Some seemed to be connected by thin channels of meltwater, threading beneath the ice like slow, invisible rivers, water pooling in one place, then draining, sometimes over months or years, into another basin nearby. If you could walk on the ice above one of these hidden channels, you would feel nothing at all, no sound of flowing water, no vibration under your boots. The ice above is too thick, too solid to carry any trace of the movement below. And yet, deep beneath you, actual liquid water might be sliding slowly from one lake to another, driven by the immense pressure and slight tilts in the bedrock far under the ice. What causes this movement is still debated. One idea is that heat from the Earth's interior, rising slowly through the rock, melts the very bottom of the ice sheet in certain spots, feeding these hidden waterways. Another idea points to the ice sheet's own weight, which can generate enough pressure and friction to melt ice at its base. even without help from the deeper Earth. Both processes may be happening together in different places at different times. The truth likely involves both. What is agreed upon is that these systems are dynamic, not frozen in time, the way the surface ice above them can appear to be. Some subglacial lakes are known to slowly fill and drain, causing the ice surface hundreds of meters above to rise and sink by mere centimeters. A movement satellites orbiting far overhead can just barely detect. It is one of the strange places where something happening in complete darkness, kilometers underground, quietly leaves its mark on the world of light above. Even now, mapping this hidden network remains incomplete. Radar surveys only cover certain flight paths. Certain regions, large areas of Antarctica's underside, have never been scanned in detail. Researchers wonder how many lakes remain undiscovered, tucked into the folds of bedrock we cannot yet see. Every new survey seems to reveal more connections, more channels, more evidence that this hidden water world is larger and more active than first believed. For now, the full map of this underground water world exists only in fragments, pieced together from radar echoes and careful guesswork. It is a landscape built from your imagination. Below the black water, deeper still, sits something even quieter than the lake itself. It is the floor, a soft bed of sediment, laid down over long ages, one thin layer at a time. No one has ever touched it. No one has ever seen it. And yet many scientists believe it may hold the clearest record of Earth's deep past that we could ever hope to find. Think about how sediment forms in an ordinary lake. Dust falls, ash from far-off eruptions drifts down. Tiny bodies of algae and other small life settle to the bottom. Over the years, these grains stack up, layer after layer, like pages in a book no one has opened. In a lake exposed to wind and rivers, that record gets stirred and broken. Storms mix the layers, currents scatter them. But a lake sealed under 4 kilometers of ice has no wind. No rivers reach it. Nothing stirs it at all. That stillness is the strange gift hidden in this darkness. If the layers at the bottom of a subglacial lake have sat undisturbed for millions of years, they may have recorded, in order, every quiet change the region went through, long before the ice ever formed. Shifts in temperature, changes in the air above, long since sealed away with the water. Perhaps even signs of ancient life that lived in a landscape that no longer exists anywhere on the surface of the Earth. You would not need to dig far to touch time most people never think about. A single meter of undisturbed mud in a place like this could span tens of thousands of years, pressed flat and patient, waiting. Here is where the surprise deepens. Some researchers believe the very bottom layers, if ever reached, could predate the ice sheet itself. That would mean the mud remembers a version of this place, with open sky, perhaps even flowing rivers or greenery, millions of years before the frozen ceiling closed overhead. It sounds almost impossible. A stretch of the coldest, darkest place on Earth once may have looked nothing like it does now, but the geology of the region does allow for it. Ice sheets are not permanent monuments. They grow and shrink across deep time, responding to slow shifts in climate that unfold over hundreds of thousands of years. Not everyone agrees on how readable that record would be. One view holds that the sediment layers are likely intact and orderly, a clean timeline waiting for careful hands. A competing view points out that subglacial lakes are not perfectly still. Slow currents can move through them, driven by tiny differences in temperature or by water flowing in from connected lakes elsewhere under the ice. Even a small current over a long enough time could blur the layers together. If that happened, The record might be more like a smudged photograph than a clear page of text. No one will know which picture is closer to true until a sample is finally taken. There is a second, quieter question tucked inside the mud. If living things have managed to survive in this lake, cut off from sunlight and the outside world, their remains might be resting in those layers too. Microbial life, adapted to cold, crushing pressure, and total dark, may have lived and died here for ages, leaving behind only the faintest chemical traces. Finding such traces would not just tell us about one lake. It would tell us something about how far life can stretch into conditions that seem, at first glance, unlivable. Picture holding a single spoonful of that sediment in your palm. It would feel unremarkable at first, cold, dark, and fine as flour. But within it might rest the compressed memory of 100,000 years, one grain resting on the next, each one a quiet witness to a slow and private history. Scientists have compared this kind of sediment core to a diary no one has read. The trouble is that opening the diary risks damaging the pages. Any tool lowered down must avoid stirring the mud, avoid introducing anything from the surface, and avoid disturbing a record that took millions of years to write. The engineering challenge is almost as delicate as the science itself. For now, the bottom of this lake remains an unread chapter. We know it is likely there. We suspect it may hold answers about ancient climate, ancient life, and the deep shape of a landscape long since buried. But suspicion is not proof, and reaching it safely is still, for the most part, an unsolved problem. Somewhere beneath the ice, that soft, dark floor keeps its own quiet counsel, layer after layer, waiting for someone patient enough and careful enough to finally ask it what it remembers. No human eye has ever seen this lake. No lamp has ever lit its water. Everything we know about it comes from instruments, tools that feel what our hands and eyes never could. Think about that for a moment. An entire hidden world, mapped and measured without a single direct look. The first tool is sound. Scientists send pulses of sound energy down through the ice, using a method called seismic surveying. The sound waves travel through the frozen layers, bounce off the water below, and return to the surface. By timing that echo, researchers can tell where ice ends and water begins. It works something like a whale calling across open ocean, except here the medium is ice, not water, and the distances are measured in kilometers of solid cold. Radar tells a different part of the story. Ice-penetrating radar sends radio waves down through the sheet, and those waves behave differently depending on what they strike. Solid ice reflects one way. Liquid water reflects another. The contrast shows up clearly on the instrument's readout. A bright, flat line where the ice stops and the lake begins. Researchers flying planes over Antarctica for decades have used this method to sketch the outlines of lakes they will never touch. Then there is gravity. A lake sitting under the ice has a slightly different mass than solid rock or packed ice would have in the same space. Sensitive instruments can detect these tiny shifts in gravitational pull as a plane or satellite passes overhead. The differences are small, smaller than anything you could feel standing on the ice yourself. But instruments built for exactly this kind of measurement can catch them, turning an invisible density change into a data point on a map. Each method has its own strengths, and each has its own blind spots. Radar shows shape and depth, but says little about temperature. Seismic surveys hint at how thick the water layer might be, but cannot map its full boundary. Gravity readings confirm that something large and dense is down there, but cannot say much about chemistry or motion. It is a bit like trying to know a room by touching only one object in it at a time. hoping the objects add up to a floor plan. Because no single tool tells the whole story, scientists layer them together. This is where the quiet harmony happens. A radar line suggests the edge of the lake. A seismic reading estimates its depth. A gravity anomaly confirms its general size and shape combined. These signals form a picture that no one instrument could produce alone. It is closer to hearing an orchestra than a solo instrument, each part playing a role the others cannot. Satellites add one more layer, watching the ice sheet's surface from far above. Some subglacial lakes cause the ice above them to rise or fall slightly as water moves in or out beneath the surface. Satellites carrying laser altimeters can measure these tiny shifts in elevation, sometimes just centimeters, across the ice sheet's surface. A lake refilling below might show up as a slow swelling above, something like a sleeper's chest rising with breath, too subtle to see with the naked eye, but clear in the data. One theory holds that many of these lakes are connected in a slow network, water moving between them through channels under the ice, driven by pressure and geothermal heat rising from below. Another view suggests some lakes are far more isolated, cut off for so long that little moves in or out at all. The instruments cannot fully settle this question yet. They can show hints of connection in some places and none in others, leaving researchers to build careful, provisional maps rather than final ones. If you stood on the ice above one of these lakes, none of this would be visible to you. You would feel only wind and cold and the vast white flatness stretching in every direction. Beneath your boots, kilometers down, instruments elsewhere would be tracing outlines you could never sense yourself, turning silence into shape and darkness into data. What remains unresolved is how complete these pictures truly are. Every method carries assumptions, correction factors, careful modeling to fill gaps between readings. Scientists agree the tools work well enough to guide missions and drilling plans. Whether they fully capture what is actually down there, in all its scale and complexity, is still an open question. The lake keeps its secrets. The instruments only listen from a distance, translating whispers of sound, radio, and gravity into the closest thing we have to sight. Every time a drill approached one of these lakes, the people holding the controls had to slow down and ask a harder question. What if the metal touching the water carried something down with it? A trace of oil, a stray microbe from the surface world, a breath of modern air. The lake below had been sealed for so long that even a small trace of contamination could change everything scientists hope to learn from it. Think of the lake as a locked room that has never been opened. If you crack the door even slightly, something from your side slips in before you can stop it. That is the fear that shaped years of planning before any drill bit touched water in Lake Vostok, deep under the Antarctic ice. Engineers designed the drilling fluid itself to avoid this problem, choosing chemicals meant to stay in the borehole and never mix with the lake beneath. Even with careful planning, the first contact with Vostok's water did not go as smoothly as hoped. In 2012, Russian researchers reached the lake after drilling through nearly 4 kilometers of ice, but pressure from below pushed lake water up into the borehole, where it froze around the drill. Some scientists worried this meant drilling fluid had touched the lake in ways no one intended. Others believed the upward rush actually protected the lake, sealing it again almost as fast as it opened. Both views still have supporters today, and the disagreement itself says something about how little anyone can verify in a place this hidden. This tension sits at the center of nearly every subglacial lake project since. Teams working on Lake Ellsworth, another hidden lake beneath the ice, built entirely new drilling systems meant to reduce risk even further. They used hot water instead of chemical fluid, filtered and treated many times before it ever touched the ice. The idea was to leave the lake as close as possible to how it existed before humans arrived with drills. Whether this fully succeeded remains a subject of ongoing discussion among glaciologists, those who study ice and the deep history it holds. The stakes of this caution go beyond curiosity about microbes. If a lake sealed for millions of years holds a chemical record of ancient air, a single contamination event could scramble that signal before anyone reads it clearly. You would be destroying a message before finishing the sentence. This is part of why some scientists argue for extreme patience. Even when the tools to look already exist, waiting another decade, they say, might mean the difference between a clean sample and a spoiled one. Other researchers push back gently on this caution, pointing out that ice itself is always moving, however slowly. Some subglacial lakes drain and refill over centuries through hidden channels under the ice, meaning contamination from natural processes may already be part of their history. If the lake changes on its own timescale, they ask, how much does one careful human visit really disturb it? This view does not dismiss the risk, but it reframes the lake as something already in slow motion, not a perfectly frozen memory. There is also a quieter ethical question beneath the technical one. Some scientists wonder whether these lakes deserve to be treated less like laboratories and more like protected places, similar to how certain caves or reefs are shielded from casual disturbance. Under this view, curiosity alone may not justify entry. Others argue that understanding these lakes could reveal something essential about the limits of life on Earth, and that this value outweighs the risk if handled carefully. Both camps agree on one point. Once you touch the water, you cannot go back to the moment before. International guidelines have slowly formed around this problem, encouraging researchers to share protocols and results so that mistakes are not repeated. Yet the guidelines remain voluntary in many cases, shaped more by shared caution than by strict enforcement. This means the protection of these lakes depends heavily on the judgment of the small number of teams with the funding and equipment to reach them at all. If you imagine standing at the edge of one of these boreholes, watching a cable disappear into darkness for hours before reaching water, you might feel the same hesitation many scientists describe. Not fear of danger to yourself, but a quiet reluctance to disturb something that has waited so long undisturbed. The lake will not react to your visit in any dramatic way. It will simply be changed in some small way forever. Whether that change matters, and how much, remains an open question the ice itself refuses to answer. There is no light in the lake, not a flicker, not a glow, not one photon finding its way through 4 kilometers of ice. And yet, if you trace the story of light in this place, you find it anyway, folded into the water itself, carried there in tiny bubbles that fell as snow before the ice sheet ever closed over the surface. Snow falls softly, layer after layer, year after year. Each flake traps a little pocket of the sky above it. Under the pressure of the ice building up above, those pockets get squeezed into tiny bubbles of ancient air, sealed inside the ice like small glass beads. As the ice sheet moves, slow and patient, some of that old air eventually melts free at the very bottom, releasing gases that have not touched open sky in a very long time. In that sense, the darkness of the lake still holds a kind of memory of light, held inside the very structure of air that once passed under open sun. Researchers who study ice cores, long cylinders drilled straight down through the ice, like a very tall, very cold cake sample, have learned to read these bubbles the way you might read a diary. The mix of gases inside can tell you how warm or cold the air was long before anyone was around to measure it. Carbon dioxide levels, oxygen levels, faint traces of ash from volcanoes that erupted and went quiet again, ages before the first human eye opened. If you held one of these bubbles up to your ear, you would hear nothing. But if you could ask it a question, it might answer with a number that reaches back farther than most of human memory combined. Here is where the mystery deepens. Once that ancient air reaches the lake and dissolves into the water, it does not stay neatly separated by age. It mixes. It moves slowly through the whole body of water, carried by faint currents driven by heat rising from the rock below. Some researchers believe this means the lake holds a blended record, an average of many eras layered together rather than a clean timeline you could read in order. Others think certain quiet corners near the bottom may hold pockets that stayed still long enough to preserve something closer to a single moment. Undisturbed and pure. No one has been able to test this directly. The lake has never given up that kind of detail willingly. There is something almost tender about it. If you sit with the idea slowly, somewhere in that black water floats a breath of air that a person could never breathe, carrying with it the ordinary weather of a day nobody remembers. A drizzle, a gust, a particular slant of light on a particular ancient afternoon, evaporated long ago, but somehow chemically sealed in. If you dipped your hand into that water, you would not feel warmth or cold in any way you expect. Your fingers would simply go numb long before your mind had time to consider what history was touching your skin. One theory holds that these trapped gases could help scientists reconstruct what the atmosphere looked like across huge stretches of time, filling gaps that ice cores alone cannot reach. A competing view suggests the lake's slow mixing has already blurred that record beyond clean recovery, turning it into something more like a smudge than a photograph. Both ideas remain open. Neither has been proven wrong, and neither has been proven entirely right. What makes this stranger still is the color question. Even though there is no color to see, if sunlight could somehow reach that water, scientists expect it would look impossibly clear at first, almost glass-like, before scattering into faint blues the way glacier ice does when light bends through very old, very compressed structures. But light never reaches it, so that blue exists only as a hypothesis, a color with no witness. The lake holds the ghost of a color it has never actually shown to anyone. So the light in this story is not really light at all. It is air. It is memory folded into water, carrying whispers of a sky none of us will ever stand under. It sits there, patient and unlit, waiting for anyone curious enough to ask what it remembers. For now, the answer stays exactly where it has always been, down in the cold, down in the dark, down where no eye and no sun has ever quite reached. Picture the ice above the lake, groaning under its own weight. That sound would carry a low, deep note, almost too low for human ears to catch without help. Scientists lower sensors into the ice to listen anyway, turning slow vibrations into tones we can hear. What they find is a kind of music made of pressure and time, the sound of a continent settling onto water it has never touched. That sound has made some researchers think beyond this one lake, beyond this one ice sheet, beyond Earth itself. If a lake this cold, this dark, and this sealed can exist under 4 kilometers of ice, other worlds might hide something similar. Ice-covered moons, far out in the cold edges of our solar system, are thought to carry oceans beneath their frozen shells. The lake beneath your feet, on this account, becomes a kind of rehearsal. It's a place scientists can study to imagine what those distant sealed waters might be like. Consider what the two settings share. Both are locked away from open sky. Both hold liquid water kept from freezing, not by warmth from above, but by pressure and by heat rising slowly from below. In the subglacial lake, that heat comes from the rock of the earth itself, seeping up through ancient stone on an icy moon. The heat may come from a different source, from the constant flexing and squeezing caused by a nearby planet's pull. The mechanism differs, but the result looks strangely alike. Dark water, no sunlight, and pressure holding everything steady in the cold. One idea, held by a good number of planetary scientists, is that if life can survive in this hidden lake without any light at all, then life might survive in those far-off oceans too. The reasoning is careful, not certain. It rests on the idea that life doesn't strictly need sunlight, only energy and water and time. Down here, deep in the ice, any microbes that exist would draw energy from minerals in the rock instead of from the sun. If that turns out to be true, it would mean sunlight is not the only door life can walk through. A competing view urges caution. Just because two places share cold, darkness, and pressure does not mean they share the same chemistry, or the same history, or the same odds of holding anything alive. The subglacial lake sits on Earth, a planet already thick with life in every corner we've checked. An icy moon sits in a colder, harsher setting, shaped by different forces across a much longer, stranger past. Some researchers argue the comparison teaches us more about method than about outcome, more about how to search than about what we will find. Still, the parallel has changed how expeditions plan their work. The same careful tools built to sample this lake without letting anything in or out are the same kinds of tools engineers imagine sending to those far moons. One day, if you could stand where an engineer stands, watching over a monitor that shows a probe easing toward unbroken ice, you would feel the same slow patience that guides work at both ends of this comparison. The instruments must be clean. The approach must be gentle. The listening must come before the reaching. That listening is where sound returns to the story, just as vibrations in glacier ice can be turned into tone. Vibrations from far-off worlds have been captured too, turned into sound by instruments built to sense what our ears cannot. The hiss of charged particles moving through space near a moon, the faint hum of a planet's magnetic field, the groan of ice shifting on a world we've only seen through a passing spacecraft's camera. None of these sounds prove that anything is alive out there. They only tell us something is moving, something is changing, something is worth a closer look. The open question then doubles. Here on Earth, we still do not know what, if anything, lives in the black water beneath the ice. Beyond Earth, we still do not know if any of those distant sealed oceans hold water at all in the way we mean it, let alone life. Each mystery leans on the other for scale and for hope, without resolving either one. What we are left with is a hush that reaches from one hidden lake all the way out to the dark side of far moons, asking the same quiet question in two different registers. For now, the answer stays sealed, just like the water it concerns. A lake sealed under 4 kilometers of ice does not belong to any one country. This creates a quiet kind of arithmetic, one made of treaties instead of numbers. Antarctica sits under an agreement signed by dozens of nations, and that agreement decides who may drill, what they may bring, and how carefully they must clean their tools before touching the dark water below. The lake itself does not care about borders, but the people studying it must move through a slow, careful system of permissions Before a single meter of ice can be pierced, think of it as a second layer of ice above the physical one. Before any drill touches the surface of a subglacial lake, scientists from different countries must agree on protocols. They must show that their equipment is clean. They must prove that their methods will not carry bacteria, fuel, or foreign material down into water that has not touched the surface world in millions of years. This process can take years. Sometimes it takes decades. The politics move as slowly as the ice itself, and in a strange way, that slowness matches the pace of the lake. There is a kind of elegant logic in this caution. If you calculate the risk of contamination against the value of an untouched sample, the numbers tend to favor patience. One dropped tool, one careless breach could end the purity of a system that took ages to form. Researchers describe this as a balance, weighing what could be learned against what could be lost forever. Some see this balance as a model for careful science. Others argue the caution slows discovery to a crawl, delaying answers that might otherwise come sooner. The agreements that govern this work are shaped by earlier ratios, older negotiations about how nations should behave in places no one owns. Antarctica has no permanent residents, no single government, no clear boundaries beyond the ones drawn by consensus. This makes the lake beneath it something rare, a natural feature protected not by walls or fences, but by shared restraint. If you tried to picture the treaty as a physical structure, it would look less like a wall and more like a series of careful checkpoints, each one designed to slow down human impulse long enough for caution to catch up. Every research team that wants to reach a subglacial lake must submit proposals reviewed by scientists from other countries. This process resembles a kind of geometry, each angle checked against every other, until the shape of the plan satisfies everyone involved. Some researchers find this frustrating, since delays can stretch a single project across years. Others find comfort in it, seeing the review process as a way of honoring how much is unknown. The lake below does not know the difference. It only knows pressure, cold, and darkness, the same numbers it has known for ages. One theory holds that this slow governance protects future science by preventing contamination that could confuse or ruin data for generations. A competing view suggests that overly cautious rules risk losing knowledge if funding runs dry before permission is granted. Both views share the same starting point. The lake is fragile, ancient, and worth protecting, even if researchers disagree on how much protection is enough. This tension has not been resolved, and it may never fully resolve, since new lakes keep being discovered beneath the ice, each one reopening the same careful debate. If you imagine standing at one of these remote research stations, waiting for approval to begin drilling, you would feel a strange mix of patience and awe. The wind outside would howl across a flat white plain, stretching to every horizon. Inside, teams from different countries would sit together, reviewing plans in quiet voices, checking numbers against numbers, making sure every measurement matched what the treaty required. The lake beneath their boots would not notice any of this. It would simply wait, as it always has, indifferent to the slow calculations happening above it. Some researchers compare this process to the mathematics of orbits, predictable but demanding immense precision. A single miscalculation in either system, cosmic or subglacial, could ripple forward for years. Here on Earth, the stakes are different but no less serious. A single mistake in this frozen work could compromise water that took millions of years to seal itself away. The politics may never fully catch up to the pace of discovery. New instruments detect new lakes faster than treaties can be updated. Yet this slow structure endures, shaped by an unspoken agreement that some places deserve more patience than curiosity alone would offer. Whether this balance is the right one remains an open question, argued quietly in conference rooms, far from the ice itself. Beneath it all, hidden and untouched, the lake continues its long and silent wait, unaware that its fate depends on numbers written not in stone, but in international paper, negotiated one careful clause at a time. No one has ever shone a light into that lake. No camera has ever floated across its surface. Everything we know about its shape, its depth, and its shoreline comes from sound. Scientists use a method called radio echo sounding. They send a pulse of energy down through the ice and listen for what bounces back. The way the echo returns tells them where the ice ends and the water begins. Picture standing on the ice sheet, in the wind and the flat white light. Under your boots, 4 kilometers of frozen weight pressed down in total silence. You would feel nothing unusual, no hum, no vibration, no sign that a lake waits below. The instruments carried across that ice are the only reason anyone knows the water is there at all. Without them, the lake would still be a rumor, a shape in the dark that no one had confirmed. The method works because ice and water reflect energy differently. Solid ice lets the pulse pass through with a certain rhythm. Liquid water reflects it back in a different way, sharp and flat, like a mirror laid on the ceiling. Researchers flying instruments over the ice or dragging them behind slow-moving vehicles gather thousands of these echoes. Slowly, echo by echo, a picture forms. It is not a photograph. It is closer to a memory built from sound. This tells us the outline of the lake. It does not tell us what moves inside it, or whether anything moves at all. That is the limit of the method, and it is a limit worth sitting with. We can measure the ceiling. We cannot yet see the broom. Seismic surveys add another layer. Small charges or mechanical thumps send vibrations into the ice, and sensors record how those vibrations travel and bounce. This can reveal the texture of the lake floor, the layers of sediment, even hints of how deep the water runs. But seismic data is coarse. It gives shapes, not details. One reading might suggest a smooth basin, A. Closer reading might suggest something more broken, with ridges and channels no one predicted. Interpretations shift as the data improves, and scientists are careful to say their models remain incomplete. Gravity measurements offer a third kind of evidence. Water is denser than ice, so its presence changes the pull of gravity ever so slightly at the surface above it. Sensitive instruments can detect that faint shift. It is a strange thought that the invisible tug of gravity can hint at a lake no one has touched. Yet gravity data alone cannot confirm depth or volume with certainty. Each method sharpens the others, but none of them removes the uncertainty completely. This is the fragile balance of subglacial science. Every tool used to study the lake is indirect. Every measurement is a guess, refined by more measurements. If the ice sheet shifted its flow even slightly, or if a sensor drifted a few meters off course, the whole picture could bend. Small errors compound over such distance and depth. Scientists check their work again and again, cross-referencing data from different years and different instruments, because a single reading could mislead an entire model of the lake's shape. One theory holds that the lake's basin has stayed largely stable for a very long stretch of time, its boundaries locked in place by the bedrock beneath it. A competing view suggests the lake's shoreline may have shifted subtly over the ages, growing or shrinking as pressure and melting rates changed far above. Both ideas rely on the same echo data, interpreted through different assumptions. Neither can be proven outright with the tools available now. If you tried to imagine the lake from these readings alone, you might picture something almost architectural, a flooded chamber with walls of stone, and a ceiling of pressing ice, silent and unlit. That image is useful, but it is still a model, not a memory. No instrument has confirmed the finer textures of the lake floor, the mineral content of its deepest corners, or whether hidden currents move water from one section to another. What remains certain is this: the sound-based methods that reveal the lake's presence are remarkably precise for something built entirely on echoes. What remains uncertain is how much those echoes leave out. The lake could be simpler than the models suggest, or it could hold shapes and features no equation has predicted. Until direct sampling confirms more, the picture stays provisional, a careful sketch drawn from vibrations traveling through miles of frozen dark. Picture the seal itself, not as a wall, but as a kind of held breath. 4 kilometers of ice rest above the lake, pressing down with a weight that would flatten almost anything. The lake stays liquid anyway, kept that way by pressure and by a faint warmth rising from the rock below. That balance has held for what may be millions of years. Some researchers wonder what would happen if it ever gave way. No one believes the ice sheet will simply crack open like a dropped jar. The break, if it ever came, would likely be slower and quieter than that. One idea is that a shift in the ice above, or a change in the flow of meltwater beneath it, could open a thin channel between the lake and the world outside. Water under that much pressure would not need a large opening. Even a narrow crack could let it move, carrying ancient water upward through the ice in a slow, hidden surge. If you stood on the ice above when that happened, you would likely feel nothing at all. The event would happen far below your boots, sealed away by kilometers of frozen rock. But somewhere beneath you, water that has not touched open air in millions of years would begin to move toward the surface, changing as it rose. What would come up with it is the heart of the question. The lake holds chemistry built slowly, in the dark, without sunlight or wind. It may hold gases trapped since before the ice sheet existed. It may hold microbes shaped by cold and pressure and endless dark, forms of life that have never needed anything we would call daylight. If that water reached the surface even briefly, it would meet an atmosphere and a biology utterly foreign to it. Some scientists see this as a kind of accidental experiment we would not choose to run. The concern is not about danger in a dramatic sense, but about loss. A subglacial lake sealed for so long is, in a very real way, a fragile record of deep time. If it mixed suddenly with surface water, or was exposed to modern air, some of what makes it valuable to study could be gone before it is understood. The seal is not just protection for us, it is protection for the lake. Others take a gentler view of the risk. They point out that these lakes are not perfectly still and closed forever. Some subglacial lakes already drain slowly through channels under the ice, feeding rivers that flow in total darkness beneath the glacier and refilling again over decades. In that light, a breach would not be an unprecedented event, only a faster version of something that may already happen gradually, in ways too slow for us to notice from above. The two views are not fully opposed. Both agree that the lake's isolation is not absolute in a strict, unbroken sense. Both agree that we do not know how any given lake would respond to a sudden opening rather than a gradual one. The difference lies mostly in how much we should worry about speed and how much damage speed alone might cause to something so old and so slowly balanced. There is also the simple physical question of what your body or any living thing from the surface would meet if it somehow reached that water quickly. The cold would be immediate and total, deep enough to still muscle and thought within moments. The pressure would press in from every direction at once, more forceful than anything felt in ordinary life, and the dark would remain complete, indifferent to whether anyone was there to notice it. Nothing about that meeting would resemble the mild transitions of ordinary weather or ordinary water, for now the seal holds. Researchers approach these lakes with a caution built from this very uncertainty, using instruments and careful drilling methods designed to avoid disturbing the balance more than necessary. Every borehole is planned to keep contact brief and contamination minimal, treating the lake less like a resource to tap and more like a sleeping thing best left mostly undisturbed. The plans acknowledge, quietly, that we do not fully know what a full breach would set loose, chemically or biologically, into the world above. What remains unresolved is not just what lies inside the lake, but how it would behave if suddenly asked to meet the surface world again. Would it settle back toward equilibrium? Or would something in that ancient water resist mixing entirely? No model has been tested against the real event, because the real event has not happened, at least not in any way we have observed. The lake keeps its answer to itself, sealed beneath the ice, waiting in silence for a question no one has yet found a safe way to ask. Somewhere in that black water, or maybe in the mud below it, something may be alive right now. Not a fish, not anything with eyes, since eyes would have no use in a place that has never known light. If life exists there, it is almost certainly microbial, small, simple, old, beyond easy counting. And yet the question of what that life might be and what it might mean has kept scientists awake for years, turning the idea over like a stone in the hand. Think about what it would take to live in that lake. No sunlight means no plants, no algae, nothing that makes food from light the way life on the surface does. Any microbe down there would need another way to eat. One theory points to the rock itself. Minerals in the lake bed may hold chemical energy, the same kind of energy that feeds microbes near deep sea vents, far from any sunlight. A microbe could, in theory, break down iron or sulfur compounds and use that reaction to live, the way a distant cousin of yours might warm its hands by rubbing them together instead of standing near a fire. Slow, patient, but enough. Another idea looks to the ice above. As glaciers grind forward over millions of years, they carry old organic material, tiny scraps of ancient plants and soil, down into the meltwater that feeds these lakes. That material could offer a thin, meager kind of nourishment. Neither theory has been confirmed. Both remain open, and it is possible both are true in different parts of the lake, or neither is true at all, and something else entirely is happening down there. What makes this more than an academic puzzle is the pace of it. On the surface, a microbe might divide and multiply many times in a single day. In a place like this, cold, starved of easy energy, cut off from the churn of weather and season, life might move far slower. Some researchers wonder if microbial generations down there could take centuries rather than hours. If that is true, then a single microbe living now might carry a kind of memory in its cells, stretching back further than most of human history. You would be looking, if you could look at all, at something that has been quietly persisting since before your ancestors built the first cities. This slowness raises a stranger question still. Biologists have spent a long time defining what counts as alive: growth, reproduction, response to the environment, use of energy. But those definitions were built by watching life in sunlight, in soil, in rivers and forests full of motion. A microbe that barely moves, barely divides, and survives on almost nothing might stretch those definitions to their edge. Some scientists wonder whether such an organism should be called dormant rather than living, existing in a kind of suspended waiting. rather than an active life. Others argue that survival itself, however slow, is still life doing what life does. No one has settled this question, and finding a real sample from the lake may be the only way to move the conversation forward at all. There is a bigger idea sitting quietly behind all of this. If life can survive in conditions this extreme, sealed away from light, crushed under kilometers of ice, feeding on almost nothing, then perhaps life is more stubborn and more adaptable than we have given it credit for. Some researchers see this lake as a rough model for other places in the solar system, distant icy moons with oceans hidden beneath their frozen shells. If microbes can be found thriving here, in conditions almost as strange as anything beyond Earth, it would suggest that the ingredients for life may need far less than we once assumed. This idea remains speculative, built on comparison rather than confirmed connection, and many scientists are careful to note the differences are still enormous. None of this has been proven. No confirmed native microbe has yet been clearly identified from the deepest, most sealed water of the lake, free of any doubt about contamination from drilling equipment. What exists instead is a set of careful, competing possibilities, each one plausible, each one incomplete. If you imagine reaching into that water with your bare hand, you would feel a cold sharp enough to numb your fingers within seconds, and you would touch something that has not touched open air or a human hand in longer than our species has existed. Whatever might be living in it, waiting in that patient darkness, has not yet told us what it is, or whether life down there means quite what we think it means up here. Think about the people who study this lake. Somewhere tonight, a scientist is asleep in a small room, and their whole career waits on a sample of water they may not touch for another decade. That is the pace of this work. It does not move like the rest of our lives. It moves like the ice above the lake, slow beyond ordinary patience, measured in seasons instead of days. Getting to a subglacial lake takes years just to plan. Teams study satellite radar for a long time before a single drill ever leaves a warehouse. They choose a site, then wait for a research window, then wait for weather, then wait for funding to renew, then wait again. A scientist might spend an entire working life circling one lake without ever seeing it drilled. This is not failure. It is the nature of studying something 4 kilometers down, sealed since before our species existed. Picture the researcher on the ice sheet, wrapped against wind that can drop the air to 50 degrees below freezing. She is looking at numbers on a screen, not water. The drill is still hundreds of meters from contact. She has trained for this moment for over a decade, and she may spend the next several hours simply watching a temperature gauge. If you stood beside her, you would feel the vast quiet of the ice press in around you, and you would understand why patience becomes its own kind of skill out here. One reason for the slowness is care. Teams do not want to carry surface microbes down into a lake that has had no contact with our world for millions of years. So they build filtered drilling fluids, sterilize every cable, test every tool in labs before it ever touches the ice. Some researchers argue this caution should extend even further, with longer waiting periods between contact attempts. Others believe the caution has already gone far enough, and that further delay risks losing funding and expertise before the science ever gets its answers. Both views come from the same worry that we might disturb something we do not yet understand. There's also the emotional weight of the waiting. Some scientists describe a strange calm that settles in after years on a project like this. Others describe frustration, watching younger colleagues finish their degrees and move on before a single sample reaches the surface. A few researchers have devoted entire careers to one lake, never seeing its water firsthand, passing their notes and models to students who will finish the work long after they are gone. This is normal in fields built around deep time. Glaciologists, like the ice itself, learn to think in a longer rhythm than most human plans allow. The lake does not know it is being studied. It has no sense of the years passing above it, no sense of budgets or permits or the careful hands preparing to reach it. It simply sits, black and still, under pressure that would flatten anything less patient than water and ice. In that stillness, our short human timelines feel almost fragile by comparison. A career is 30 or 40 years. This lake has been sealed for longer than our species has walked upright. Some researchers find comfort in this contrast. They say working on something so much older than themselves gives their work a kind of quiet meaning, separate from the usual pressures of fast results. Others say the uncertainty is exhausting, since a life's work might end without a clear answer about what, if anything, lives in the dark below. Both experiences are common in this field, and neither one is wrong. The lake asks nothing of the people studying it. It simply waits, the way it has waited for millions of years already. If you spent a season on that ice, your sense of time would slowly shift. The sun would circle without ever fully setting or without rising at all. Depending on the season, days would blur into a single stretched moment, and the drilling schedule would become the only clock that mattered. You would begin to understand why the scientists here speak of patience not as a virtue, but as a requirement, the way you might speak about breathing. We still do not know exactly what these long efforts will find. Maybe the samples will show simple microbes surviving on chemical energy alone. Maybe they will show nothing living at all, just ancient water and old, trapped air. Either outcome would take years of careful analysis, and even then, some questions might remain unanswered. The lake will still be there. The waiting will simply continue, the way it always has, in that long, dark room beneath the ice, far below any human clock. Somewhere south of everything you know, the ice sits quiet under the stars. 4 kilometers down, the lake is still there. It has been there through all of this telling, patient in a way nothing on the surface of the earth is ever asked to be. Tonight, as you rest under your own low ceiling, that other ceiling of ice rests too, thick and blue and silent, holding its shape the way it has for longer than there have been minds around to wonder about it. Think of the water one last time, not to solve it, but just to picture it. Think of the deep cold that never freezes because the weight above will not allow it. Think of the dark that has never once felt the change of a single day. No morning, no evening, only the same total black, endlessly. Think of the stillness, no wind to stir it, no moon to pull a tide through it. Nothing moving except perhaps, somewhere in that patient water, the smallest forms of life, doing the slow work of simply continuing to exist. We have asked, across this long night, whether anything swims down there. We do not know. We have asked whether the chemistry sealed inside that water holds some memory of an older air, older than any word ever spoken. We think it might. We have asked whether other lakes like this one lie scattered under the far ice, linked by slow rivers no eye has seen. And the answer seems to be yes, though the map of them is still unfinished, still being drawn, one faint signal at a time. Every one of these questions stayed open. That was always the plan. Some mysteries are not meant to close before you sleep. They are meant to be carried gently into it. If you could stand at the edge of that lake, which no person ever truly will, the weight of the ice above you would be a kind of steady, silent pressure, more than anything your body has ever felt. The cold would settle into you slowly, patient rather than sharp, and the dark would simply be there, complete, the way it might feel to close your eyes tonight and find that the closing barely changes anything at all. Perhaps that is the last quiet thing this lake can teach you. Darkness like that is not empty. It is only very, very old, somewhere above the ice sheet tonight. The sky is doing what it always does over that frozen ground, turning slowly, indifferent to depth or ambition, scattering faint starlight over a surface that has not asked to be understood. Below, the lake keeps its own separate hours, if hours mean anything to something enclosed. For millions of years without a season, it has outlasted the arrival of the people who first thought to look for it. It will likely outlast the drills, the sensors, the careful international agreements about how gently to approach it. It does not know it has become a question. It is simply water, sitting where it has always sat, waiting for nothing, because waiting requires an expectation. And down there, nothing has arrived to be expected in longer than memory can reach. That is the shape of this mystery, and maybe the shape of rest itself, somewhere far beneath your feet tonight. Something ancient and enclosed continues quietly on, unbothered by the passing of your one small night, somewhere far above your ceiling, in skies you cannot see from here. Other dark and distant places turn just as slowly, just as unconcerned with being solved. You are, for this moment, held between two kinds of vastness, one buried in ice, one scattered in the dark overhead, and neither one requires anything from you except the willingness to imagine it. So let the lake stay sealed, let the dark stay dark, let the question rest exactly where it is, unfinished, patient, and safe from any hurry. There is a kind of comfort in a mystery this old. It asks nothing of you tonight, but a little wonder, and wonder, unlike answers, costs you nothing and asks for nothing back. Somewhere below the ice, the water keeps its stillness. Somewhere above you, the night keeps its own. Let your body follow the water's example and settle, slow and heavy and calm, into a stillness of your own. Thank you for spending this long, quiet night with a question that may never fully close. We may learn more about that hidden lake in the years ahead. We may not. Either way, it will still be there, keeping its dark, keeping its cold, keeping its silence, exactly as it has for millions of years before this one. Subscribe for a brand new Earth topic every night. One tap, and something wonderful is waiting for you tomorrow. Sweet dreams.